Hello everyone, it's Ray Aslan again. I am here to continue the AWS labs with you. In other videos, we did AWS lab number 1 and lab number 2, where we created a FortiGate inside of a VPC, just did a simple inbound policy to allow RDP access to a Windows server in a private subnet. We also created a dynamic address object using the Fabric connector, and we allowed outbound policy through that same FortiGate so that that Windows server could then go out to the internet. And then finally, in lab number 3, we deployed a FortiWeb and had a VIP on the FortiGate direct traffic to the FortiWeb for port 80, where the FortiWeb processed traffic and potentially allowed it to the web server, which was also running on Windows. Now, the reason I reference those labs is we're going to use certain elements of labs 1, 2, and 3 in lab 4. In lab number 4, let's just erase the ink there and go back to my, there we go, my mouse clicker. Very good. Let's get this out of the way. We'll zoom this in a little bit. In lab number 4, we're going to use the VPC that we created earlier. So if you're following along, first of all, this lab is going to be a little bit more complex. I would suggest watching the entire Lab 4 video and then watching it again and in real time trying to perform the labs, pausing as you go. Because in this lab, first we'll start off with using the existing VPC, lab VPC that we see here, which is a 10.0/16 VPC. We'll start off with using the two subnets you've already created, the public subnet and the private subnet, and I'm going to draw each subnet in a different color. So let's just say the public subnet is in red, the private subnet is in blue, right? Private subnet's in blue. In addition, we're going to add a couple of more subnets. Let's do the HA sync subnet. So this is going to be high availability. We're going to use FortiGate clustering protocol and do an active passive HA in a single availability zone. Active passive HA in the cloud works a bit differently than it does on-prem. There is a heartbeat, and we have to have a heartbeat network. And this is the network that, similar to heartbeat on-prem, keep alives are effectively sent where the standby unit or the secondary unit sends to the active or the primary unit, are you alive, hello messages, and make sure that it's still responding. What's different than on-prem? It's a unicast heartbeat. We can't do broadcast heartbeats or multicast heartbeats because there's no broadcast or multicast in the cloud. So there's going to be a subnet for that. It's called the HA sync subnet. It's also where config synchronization is done. So remember, in HA, we have to sync up our firewall policies, our objects. All of that configuration synchronization happens on the heartbeat network. So that'll be that middle subnet there in green. Well, that's 3 subnets. There is a 4th subnet that is used, a management subnet. Let's change colors, change pen color, and here we go. We've used red, green, blue. Let's use purple. I like purple. Purple is going to be our management subnet. And I'm going to have to draw this as 2 circles because of the way this drawing works, but this is just really one subnet both FortiGates are connected to. This management subnet right here. I know that it looks like 2 circles. It's really the same subnet. It's the 10.0.40/24 subnet. Now, in HA, to allow inbound access and outbound access to the internet, we're going to have an elastic IP address that's associated with the interfaces in the public subnet. Let's just do a little spotlight right here. So there's going to be an elastic IP, and I know I've drawn all over this diagram, but this is this elastic IP. And effectively what's going to happen is the elastic IP address is only going to be associated with whoever the current master or primary member of this active passive HA cluster is. So if this FortiGate is the current master, then the elastic IP is going to be associated with this. Now keep in mind, between these two guys is still a heartbeat, a unicast heartbeat. And if this is the secondary and he's heartbeating the primary, and the primary stops responding, he wants to take over that elastic IP address. So he has to go and tell the AWS cloud to associate that elastic IP with his port 1, with his private IP address on port 1. That communication is an API call, and that API call happens from the management interface. Let's just switch over to a pen here, and we'll go back to purple. Pen color up, I'm still set to purple. And so if it's going to go and take over being active, it's going to send that API call this way. Oops. Let's try this again. Purple, there we go. And so it tells the AWS cloud, assign the elastic IP address to me. In addition, remember from lab number 1 that the FortiGate is part of a routing table entry so that elements inside of private networks can go outbound to the internet. So in addition, it has to tell the AWS cloud to update the private routing table to point to it as well. These API calls are only made when a secondary system takes over as primary. It has to be made by the secondary system because the primary system is down at that point. It's not working. So it has to have a network interface to make that call. That's the HA management subnet. In addition, the interface on the HA management subnet is also associated with an elastic IP of its own. This is not an elastic IP that moves back and forth to whoever the active is. This is an elastic IP, so I'm just going to write EIP over here. That is always associated with that interface, so that that interface can make API calls out on the internet, even when it's not the master. Sorry about the handwriting there. That looks awful. That P doesn't look much like a P at all. And let's just try this again. Little slower. EIP. That's a little bit nicer. So that management interface can make API calls so that we can reach that management interface even when it's not master, so that we can actually manage that system when it's not master. There's going to be another elastic IP address that's over here. That's always over here as well. EIP. See if I can fix my E. Well, okay, that's as good as that EIP is going to get. Sorry about the handwriting. I type for a living. What can I tell you? So that's the purpose of these purple networks, so that we can reach that FortiGate even when it's not master. The elastic IP address that's on the public subnet, that's for clustered traffic. We fail that back and forth so that whoever's master has the ability to talk outbound to the internet, or if we have VIPs, the VIPs have inbound traffic that are associated with that elastic IP. I'm going to go ahead and pull down all of this ink, all these drawings that I've done or saw, and put ourselves on a regular mouse click here, and we'll pull this over to my side. So I'm going to need to create more subnets. I have a public subnet and I have a private subnet, but I don't have a sync subnet or a management subnet. I'm also going to have to make some adjustments to routing table entries, and I'm going to need to create an S3 bucket. The S3 bucket, let's just talk about the S3 bucket for just a second. An S3 bucket is a storage location, and the S3 bucket will be used to keep a bootstrapped config of the FortiGates. Now, normally, if you deploy a FortiGate image, it doesn't already have HA configured on it. But when these FortiGate images deploy, they're already going to have HA configuration. Those configurational commands are stored in an HA bucket and loaded onto the FortiGates when the FortiGates first boot up. So that'll be the purpose of this S3 bucket. And when we're done, we should be able to go into that S3 bucket and see these config files. And it's just the basic HA configuration needed to bring up a FortiGate and join it to the cluster. Let's go ahead and start doing some configuration so that we can get our environment caught up with what we need here. Let's go to the S3 bucket first. So I'm going to go to services, and underneath storage, we've got S3 right there. S3, I'm going to click on that. Now, once again, this is another one of those pages where they've had different revisions of the console. So you can see here a little note at the very top. While we continue to improve the new version of the S3 console, you can temporarily switch to the old version. Yep, I'm using a new version of the S3 console. So if your screen looks a little different than mine, perhaps you don't have an orange create bucket in the right side there, I believe that you will have a blue bar that says something like, there's a new version of this console. Click here to switch to the new version. If you click on that, you'll have a console that looks just like mine. And while the basic options should be the same, it will help your wizard or your deployment steps look closer to what my deployment steps look like. Let's go ahead and click create bucket, the create bucket button, and start making our S3 bucket, which is, again, just remember, it's just a storage location. Now I need this S3 bucket name to be unique, and so I'm going to give it a name with my name on it, and I'll use today's date as part of the name, 09/08/2020. That way, and this is unique even with other AWS customers. So it's pretty unlikely that there's another customer out there making a bucket named R. Aslan. It's not that common of a last name. Or R. Aslan with today's date at the end. I need this bucket to exist in Ohio, US East 2. That's where all my resources are going to be created. So let's go ahead and choose there. There are a lot of other options here. I don't need public access. So really I could just be able to take the rest of these and leave them at defaults and say create bucket. So this is just going to be a bucket that's accessible by my FortiGates, and it's actually only going to be accessible within the private subnet, or if I logged onto the console, I can go and see the contents of this bucket. All right, well, there's my bucket, R. Aslan 09/08/2020. I'm going to need that bucket name a little bit later. So I'm going to copy it and I'm going to paste it into Notepad. Very good. Next, let's go start prepping the VPC. Let me minimize this Notepad down. It's just going to get in my way. So we'll go to services, we'll go to VPC. This will take us to the VPC console. From there, we'll go to subnets. Because one of the first things we're going to need to do is have to add a couple more subnets. We need the HA sync subnet, the HA management subnet. Let's go to subnets. Now this particular example of high availability, everything's going to be located in a single availability zone. This is going to be single AZHA. So what I'd like to do is find out what availability zone everything else that I've deployed is in. It's in US East 2A, which is basically the US East 2 region availability zone number 1. A is zone number 1, B is zone number 2, C is zone number 3. So there we go, US East 2A or US East 2 availability zone number 1. So the other subnets I create, I'm gonna make those in the same zone. Let's go ahead and create some other subnets. Let's say HA sync. This is gonna be for heartbeat traffic. This is going to be for config synchronization traffic. We're going to put it on the lab VPC, and we'll put it on US East 2A. And it's going to be 10.0.3.0/24. Just to remind ourselves, 10.0.0/24 is the public subnet. 10.0.1 is the private subnet. I'm not going to use 10.0.2. I'm going to use 10.0.3 and 10.0.4. So here we go. 10.0.3 is going to be sync, HA sync traffic. And we'll create another one for HA management. HA, MGMT, very good. VPC, the lab VPC, please. Same availability zone. A right there, yep. And we'll get this to 10.0.4.0/24. Create. Let's go look at my routing tables. Now, recall I have a public routing table and a private routing table. The public routing table has a route that says to get to 0000/0, go to the internet gateway. Now that's important because I can assign elastic IP addresses to things that plug into this, to the subnet associated with this routing table, and the elastic IPs can route out to the internet and destination NAT back into things inside of in that public subnet. The HA management subnet is going to have elastic IPs assigned to it or assigned to resources in it. So it needs to be associated with the public routing table. There is also a private routing table. My private routing table, right now, it only has one route, the 10.0.0.0/16. If you are using the routing table that you created in Lab 1, 2, and 3, there is probably a second route that shows up here. And it currently says that it's black hole. It's a default route. It's a 0000/0 route. And it's pointed to an ENI, and it says that it's black hole. The reason that that route, well, first of all, the reason that it exists is we created it earlier in an earlier lab. The reason that it's black holed is we actually deleted that ENI a little bit earlier. So that black holed route, if you would like, you can click Edit Routes, and you'll have a second line in here with that black hole route, and off to the right of that second line will be an X or a black X, and you can use it to delete that route and then click Save Routes, and that'll get rid of that black hole route. If you haven't created, if you're created fresh VPC and fresh subnets for all of this, then that black hole route won't be there. In any case, we're going to update that route later. So, but I would go ahead, if you got the black hole route, just go ahead and delete it so it's not bothersome. It's not, you're not wondering what it's doing there. Let's look at subnet associations. The private routing table, as we created things earlier, it's the main routing table, which means it was the default for this VPC, which also means that if I create new if I create new subnets, they automatically associate with the private routing table because it is the main routing table for that VPC. So when I look down here, first I can look at the top where it says main there, and I've highlighted yes, I know this is the main routing table. I know it's the default. And then I see this message under subnet associations. It says the following subnets have not been explicitly associated with any routing tables, so they're associated with the main. This is telling me these three subnets are associated with the main table because you haven't explicitly included them with a different routing table. And if we look carefully here, it's all of the subnets except for public. I need this HA management subnet not to be associated with private. I need it to be associated with public. So what I will do is go over to public, go to subnet associations, choose edit, and I will include it. I'll go HA management. So I'll have both HA management and public selected, and I'll click save. And what's going to happen is instead of management being associated with the main table, it's going to be associated with this public table that I created. There we go. Now, under the public table, I see both of those networks. Under the private table, I only see private and HA sync. That's what we're looking for. On private, we only want the private subnet and the HA sync subnet. On public, we want the management subnet and we want the public subnet. Because we want both of those to be able to take advantage of the internet gateway, since both of those subnets will have ENIs that have elastic IPs associated with them. In addition, I'm going to need some information later in my deployment. I'm going to need the routing table ID of my public subnet. So what I'm going to do is I'm going to get Notepad back up here. Here's Notepad. I'm just going to say public subnet route table ID. A little bit earlier, I mentioned to you guys the names that we give things are just really there for human beings. Sometimes when we're interacting with AWS, we have to give the identifier. And that's what's going to happen here is I'm going to need this identifier. So what I'm going to do is I'm just going to highlight that and type in Control-C to copy, and then I'll paste this right here. Control-V, there it is. And I don't remember if I need the private route table ID. But just in case I do, let's go ahead and copy and paste that one too. I don't think I do, but I'd rather go ahead and get it now while I'm over here on the screen. Here we are, little space in there. Very good. All right, we'll minimize this down and come back to it shortly. Okay, we have our VPC, we've got our 4 subnets, and we've got our S3 bucket. Not all CloudFormation templates require the creation of an S3 bucket. But, oh, you know what? CloudFormation templates. I don't think I mentioned that yet. CloudFormation templates are JSON files that describe resources that you would like to deploy, and they can help automate more complex configurations. A single HA protecting a subnet, you probably don't need a CloudFormation template. But with what we're going to do next, it probably would be helpful to use a CloudFormation template so that when FortiGates deploy, they automatically plug into the management subnet with the management NIC, the HA sync subnet with the heartbeat network interface, the public subnet with the public interface, the private subnet with the private interface. There's a lot of different moving parts, and CloudFormation templates can simplify that deployment, make them a little bit less error prone. So we're going to go get a CloudFormation template. CloudFormation templates are found on GitHub. If we go out to, I think I might even have it favorited over here. You know what, I do have it favorited, but let's actually navigate to it from here. www.github.com/Fortinet. Here we go. So these CloudFormation templates, they're JSON files. They're found out on our GitHub on github.com/Fortinet. We're going to use the AWS templates, AWS CloudFormation templates right there in the middle. We're looking for the HA templates, and there's an HA folder right at the top. And we're going to do the 6.2 version of the templates. And we're going to say single availability zone, because that's what I'd set up with my VPCs earlier. Everything was in a single AZ. Now within that folder, there's 2 JSON files. There's an existing VPC JSON file, and there's one that does not say existing VPC. So this top one, base VPC, FGCP single AZ, probably deploys, yeah, it says base VPC. It probably deploys a new VPC. I already have a VPC with 4 subnets in it, routing table entries. Let's go ahead and deploy the one with the existing VPC. So I'll click on it. And this is the actual JSON file contents that we see down here. And it describes resources. It also allows for variables to be input, which are called parameters. So during the deployment of the template deployment process can ask you things like, what subnets are you using and which subnets do you want to use for which purposes? Are you doing bring your own license or pay as you go? It can ask you things during that process. I've already downloaded this template, but I'm going to go ahead and download it again. There's lots of different ways of downloading the file. I like to just right click on the raw and say save link as. This is Chrome. Chrome will ask me where do I want to put it, and I'll choose, it's actually already out there. Here we go. I'll just tell it to do this. I think it'll ask me and I can replace the existing file. Let's see, save. Yes, let's go ahead and replace the existing file that I have there. And there it goes, it's downloading. Well, now I have this JSON file. I need to go to AWS and deploy it. I think I was in route tables a little bit earlier. I was in route tables. Let's go to services. And if you've never visited it before, if you look underneath management and governance, about the 4th item down the list is CloudFormation. Let's go to CloudFormation. Okay, very good. So when we deploy with a template, we're going to deploy a stack of resources. Let's say create stack. It's going to ask me some questions. Most important one right now, do you have a template already? Yes, I do. My template is ready. I'm going to upload a template file. So we'll just say choose file. And there's the file, FGCP single AZ existing VPC template.json downloaded just a moment ago. Very good. Let's choose next. So it's going to ask me parameters. It's going to ask me for input to clarify certain parts of the deployment of this template. There are some things in this template that are not statically set that we want to ask customers before we deploy the template, like which subnet do you want to use for public, and which do you want to use for private, and which one do you want to use for heartbeat traffic. So first of all, it wants to know the name of the stack. Every time you deploy a CloudFormation template, it's creating a stack. That stack has a name. It shows up in a list. You can go and do various things to that stack later, including delete. You can delete everything in a stack. So since this is high availability, I'm just going to call this FortiGate HA. All right, wonderful. This one is for an existing VPC, so it wants to know which VPC I plan on using. I only have one VPC, the Lab VPC, so there it is, and fortunately it lists the name for it, makes it nice and easy. What's the VPC CIDR? Well, very fortunately, if I had any doubts at all, it's listed in the output just above that, so 10.0/16 works fine. Which subnet do you want to use for public traffic? Which subnet is associated with an internet gateway where the elastic IP address is going to exist that fails over back and forth? Well, I named mine public, so let's choose public. Which subnet is the private subnet? Where are the protected resources going to be connected? Well, the private subnet, 10.0.10/24. Wonderful. Which subnet do we use for heartbeat and config synchronization traffic? The HA sync subnet, 10.0.30/24. And which subnet should we use for management traffic? Remember, this is the subnet that needs to also have a route out through the internet gateway, because elastic IP addresses will be associated with each FortiGate on this subnet and needs to be able to access out to the internet. HA management subnet, 10.0.40/24. Great. C5 extra large. I am going to go take the C5 extra large. This deployment has a lot of network interfaces, so I need a relatively large FortiGate. CIDR for instance access. If I didn't want my FortiGates to be accessed from any network, let's say if I knew a range of public IPs that my management traffic could always come from, I could specify that here. But for me, 0000/0 is most appropriate right now. Key pair, just like when I deployed FortiGates, it wants to know what my key pair is. I skipped one, I'll come back to that one here in a second. So earlier I made the lab key pair. There we go. Availability zone for instances. Keep in mind the deployment that I'm showing you, everything is in a single availability zone. So this relates back to the AZ that I saw earlier. And this was US East to A, or availability zone number 1. S3 endpoint deployment. A little bit earlier, we talked about this S3 bucket. First of all, reminder, S3 buckets are object-oriented storage. It's a place to store files. The files in this case will be a bootstrapped configuration. It'll be a base configuration that gets loaded onto a FortiGate so that it can form an HA pair. So there'll be, I think, IP address, static route, the base configuration of HA, those portions that would not automatically be on an image just because you deployed a new image. So that the idea here is you deploy these and you don't have to go and run all these FortiOS commands. That's what's inside of these config files, are FortiOS commands that get bootstrapped into our FortiGates. The endpoint. A resource endpoint is like an elastic network interface, but it's not associated with an EC2 instance. It's associated with a service like S3 storage. This allows my S3 storage to be accessed inside of my VPC so that this doesn't have to be a publicly accessible storage bucket. This is supposed to be in my, we'll say, first of all, I don't have a service endpoint configured already. I have a bucket deployed, but I don't have an endpoint deployed. The endpoint is kind of like the elastic network interface for it. So I'll tell it to deploy new, and it's going to be in the public subnet. So there's going to be this basically elastic network interface that plugs in the S3 bucket in the public subnet. And it is in the public subnet, but the only thing that's going to be that's going to be accessing it is my FortiGates. It asks me for the public subnet routing table identifier. And it says, hey, if you're deploying a new S3 endpoint, we need this. They're probably going to write a route to it. Within it, let's go in here, route table ID for my public subnet. I jotted this down a little bit earlier. Copy, and I'm being very careful not to get like extra spaces in there. I don't know that an extra space at the end would break the process, but I'm not willing to find out right now in real time for you, sorry. Okay, the init S3 bucket. This is where your config files are going to be loaded. By the way, if you're doing bring your own license, this is also where the license files would need to be uploaded to for your FortiGates. We're doing pay as you go, so we won't be uploading anything like that there. This is the name of the bucket that I created a little bit earlier. This one, Control C, Control V. Very good. There's no spaces in there, right? Nope. All right, well, what region is this bucket in? It's supposed to be in the same region as the resources that are accessing it. So let's just say it's in US East 2, otherwise known as Ohio. Right. License type, pay as you go. We're using pay as you go. Now, I mentioned earlier, if you're doing bring your own, you upload the license files into the bucket. You would also have to give it the names of those files in the bucket so that it knows what to look for in the bucket. We're not going to do bring your own, we're doing pay as you go. I can just leave those as blank. All right, now it wants to know what IP addresses we're going to assign to certain things. So first of all, we have router IPs. These are not the FortiGates IP address. This is the intrinsic router. It's the first IP address of every subnet. There's always a built-in cloud-based router that knows how to route to things within the VPC, and it's also what kind of obeys the routing tables that we create. It's not really a router per se. It's not like an actual distinct device. It's a service. It's used all the time. And so that's all it's asking us for here. And these are the correct IPs. We don't need to change, but one of these is actually incorrect. Actually, as I look at it, these are all a little far off since the IP addresses are within their subnets. So the public subnet router IP is in the public subnet, which is 10.0.0.1. The private router IP is in the private subnet, which is 10.0.1.1. The management subnet router IP is correct. That's the .4 network. We'll just double check real quick here. Sync is 10.0.3.0. Management is 10.0.4.0. So let's come back down to here. So the management subnet 10.0.4.1. So these values are preloaded that were in here before. Were preloaded in the CloudFormation template file that I used. And clearly they were expecting someone to use slightly different subnets than what we used, slightly different CIDRs. So I did 10.0.0.1, 10.0.1.1, 10.0.4.1, because those reflect the actual subnets for each of those purposes, right? Public is 10.0.0/24, private is 10.0.1/24, sync is 10.0.3, oh, actually let's skip sync for a second. Management is 10.0.4.0/24. How come it didn't ask me about anything about the sync subnet? Probably because nothing needs to route out of that network. The sync subnet is basically just exists between the two FortiGates for unicast heartbeat traffic. That's probably why it's not asking. That's not an official answer, by the way. That's just me taking an educated guess. All right, so it says now I've got these two FortiGates in this HA cluster. What IP addresses do you want to use for each of the respective network interfaces? Well, clearly the default values expected me to use slightly different subnets than I did. So the public IP, I want to be 10.0.0.11. The private IP, I want to be 10.0.1.11. The sync IP, 10.0.3.11 works just fine. The management IP, 10.0.4.11 works just fine. So it's really just my public and private that are slightly incorrect. So basically, FortiGate number 1 has the .11 IP on all of its respective subnets. FortiGate number 2 is going to get the 12 IP in its respective subnets. And since the public subnet is 10.0.0, we'll change that to 10.0.12. And the private subnet is 10.0.1, we'll change that to 10.0.1.12. 10.0.3.12, 10.0.4.12, that will work just fine. And then we have clustered IPs. Now this is a secondary IP that can be moved back and forth by the AWS console. This is a little bit like on-prem, right? On-prem, we have an IP, we have a floating IP that floats back and forth between the primary and the secondary. we have something very similar here, but it's not the primary IP, it's a secondary IP. And the reason this happens, if you go back to lab number 1 and number 2, one of the things that you might have noticed is when we configured an elastic IP address, let me give myself a pen and we'll draw in black. When we configured an elastic IP address, the elastic IP, part of that configuration associated it with a private IP. Right? And there was also this configuration where it was also tied to a particular ENI, right? So this EIP, destination added to a private IP that was associated to a particular ENI. And with this clustered configuration, what we're going to do is we're going to tie the elastic IP to a private IP that moves back and forth. It's going to be, here, we'll change it over here on the right real quick. Let's just go back to my regular clicker, 10.0.0.13, right down there, 10.0.0.13. What's going to change dynamically is when someone else takes over as master, the private IP is going to move to a new ENI, which is going to make the elastic IP come with it. So if you could imagine this as, let's go back to drawing tools and pen. Let's say that this is ENI number 1, right? And FortiGate 1 fails, and it goes back and goes, okay, we'll change it to ENI number 2. And that's what's going back and forth. And then, oh, if FortiGate number 2 fails, but FortiGate 1 is back up, oh, okay, it's going to reconfigure the cloud and go back to ENI number 1. That's supposed to be a 1. So that's why it's asking for this relationship. Let's go ahead and say erase all drawings. And very similarly, we'll do something very similar on the private subnet. So on the private subnet, this is going to be 10.0.1.13. Let's change back to a mouse pointer, not a pen, 10.0.1.13. Very good. So when I click next, I should get the opportunity to confirm what I'm doing. Stack creation options, roll back on failure. Yep, rolling back on failure. This is kind of an interesting one. If I'm having a stack that's failing deployment, you can turn off the rollback. Rollback means delete everything you created. That way I can go and see exactly what's getting created and what's not. But hopefully I have done this correctly and it's not going to roll back on failure. It's going to go roll forward on failure. So let's go ahead and say next. A little review, everything that I typed in. If I wasn't certain that I did something correct, I could look through that now. And then down here at the bottom, the following resource capabilities, IAM role, identity and access management. This is going to create access to my cloud, API access to my cloud. During lab number 2, when we talked about fabric connectors, we mentioned metadata access. Instead of creating a user credential for API access, a EC2 instance could be granted direct access, where you could go to the metadata of that EC2 instance and simply say, this instance has this role or this access policy. It has read-only or it has read-write. And that's what this is going to create. And the reason it's going to create it is, remember, when a secondary takes over the cluster, it has to go make API calls. It has to tell AWS, point the elastic IP address to me, change the routes to me. And that API call requires writes. So this is creating that metadata rights so that those instances have those rights. Let's go ahead and just acknowledge that it's going to do it. Otherwise, I won't be able to continue. And let's click Create Stack. Now, this is going to take a couple of minutes. We see Create in progress. I'm going to go ahead and pause the video. We've been going for a little while. It's a good time to take a little break. I'll pause the video, and when I come back, hopefully it'll say Create Complete. Be right back, everybody. All right, well, I've stepped away for just a couple of minutes. And I'm resuming the video now. Got my screen still here. Let's go over. It says new events are available. Let's just hit refresh. There we go. I see many create completes in there. Let's refresh over here on the left side. Create in progress. Still going. Okay, well, I'm going to go back to taking a break, and I encourage you to do the same. Of course, this is all virtual, so you can unpause your video anytime you want. But for those of you who are following along on your own, what I realized was I didn't tell you how to click refresh. So if you click refresh on the right, it shows you basically all the kind of subtasks that are getting kicked off. And many of them will only say create in progress, and many of them don't go to a green arrow. But this event on the left side, FortiGate HA, the name of the stack, it eventually should say, there you look at that, create complete. It eventually should say create complete like it does on the left side. And then finally, the last thing that you'll see on the right side is a task or an event name with the name of the stack, FortiGate HA, that says create complete. So there we are. We are indeed created. So let's go take a look at what it created for us. If we go to the Outputs tab, the Outputs tab is going to give us various pieces of information about what it deployed. I see there's a cluster login URL, there's a FortiGate 1 login URL, and a FortiGate 2 login URL, a username, a password, which looks like an instance ID, and a username. Well, first of all, about this FortiGate login 1, FortiGate login 2. All three of these are elastic IPs. There's three different elastic IPs here. The one that says cluster, this is the elastic IP address that moves back and forth to whoever the current active FortiGate is. So that's the one on the public network. FortiGate 1 login URL and FortiGate 2 login URL, these are on the respective management IP addresses. These are the elastic IPs on each HA management interface. So what I should be able to do, let me move this little drawing icon over here to the corner and open up a couple of extra tabs. Well, we don't need this anymore, and we don't need this anymore, and at the moment I don't even need that. But I do want, maybe I can move that to that corner. There we go. I do want these. I'm just going to grab the whole thing, put it in Notepad, so I don't have to go back and forth if I need it. First, let's see about hitting these guys on their individual management IP addresses. So we'll go to FortiGate login 1 URL, FortiGate 1 login URL, there we go. And we'll use username admin and password is the instance ID. Copy, advanced, proceed, normal, certificate errors for a self-signed cert. Nothing special about the cloud there. Since I've already gotten this data, I'm going to go over to services and EC2, because it occurs to me that my EC2 instances might not have finished starting or syncing yet. It says I have 2 running instances. There we go. FortiGate HA, FortiGate 1, FortiGate HA, FortiGate 2. I see status check still set up to initializing. These might still be booting up for the first time and syncing up HA. I'll sit here and refresh and see if it'll let me in. There we go. Accept and admin. Now, normally when you deploy a FortiGate, the admin password for the first time is the instance ID of that FortiGate. But this is telling me that both FortiGates have the same password. It's this instance ID. And I'm not going to go through the entire thing, but it ends in 50379. Why do both FortiGates have the same password? It's an HA configuration. They sync their config. And really what happened was FortiGate 1 was the master on first boot, and so his password was his, I don't know how it was assigned a gender, its password was synced to FortiGate 2, which is why I should be able to hit either one of these and log in with that password. Let's go ahead and log in to FortiGate 1. It says, hey, why don't you change your password? Sure. Here we go. FortiGate 1's host name is FGT1. Wonderful. System and HA. And I do have HA configuration, but it looks like FortiGate 2, the current secondary, has not finished syncing up yet. That's not very unusual. If I deploy HA, it is not uncommon at all for me to get logged into FortiGate 1 before FortiGate 2 has finished syncing up. And that's why I've got that little red X down there. So not altogether shocking to me. And I'll wait a couple minutes and I'll refresh it again and we'll see if I can still get in there. So, or rather, we can see if I can get in there and everything is synced up. However, let's go ahead and use the cluster IP and see if the cluster IP is taking me to FortiGate 1. So here's the cluster login URL right here, copy. So the IP address that ends in .127, that is just FortiGate 1. That is its HA management interface. Let's open this second tab and point to the clustered one. And it looks like it's going to come up as well. Admin. Indeed. Let's go to, yep, FortiGate 1, same FortiGate. While we're waiting for HA to sync up, let's look at a few other things. So when we click on FortiGate 1, who's the current master of the cluster, who has the clustered elastic IP pointed at him, let's just take a look at his config. He has the .11 IPs. So if we look down here on private IPs, we see that he has 1.11, 0.11, 3.11, 4.11. So he's got a .11 basically in each subnet he's associated with. He has two secondary IPs associated with him, 1.13 and 0.13. These secondary IPs are part of what's going to fail over back and forth in HA. So if we look at FortiGate number 2, who is the slave or the secondary, the non-primary unit, he's got the 12 IPs, 012, 112, 312, 412, but there's no secondary IPs because he's not the master of the cluster right now. There we go. If we look at the elastic IP addresses, FortiGate 1 has two elastic IPs. One of these elastic IPs go to its management interface. The other elastic IP goes to its clustered interface. It owns it because it's the master. Whereas FortiGate HA2 or FortiGate 2 only has one elastic IP, just the one for its management interface. There it is, .50. Let's go have a look at elastic IPs. And we can see, let's pull this out a little bit. Here we go. This is the clustered IP that fails over back and forth. Notice the private IP address that it's associated with is associated with 10.0.0.13. It's not with 11, it's not with 12, it's with 10.0.0.13. And these other two are associated to 10.04 IP addresses, 11 and 12. When a failover occurs, this private IP address won't change, but which network interface owns that private IP address will. That's what's going to change. So just for fun, let's just jot this down because we're going to do a test failover here in a couple of minutes. Let's say highlight, Control C, Notepad, and we'll call this FortiGate 1 public ENI. There it is. And just for the sake of it, we'll say FortiGate 2 public ENI, and we'll go grab it as well. Instances, FortiGate 2, and that would be the ETH0 network interface. So I'll click on ETH0, and there's the ENI. Copy. If I had any doubts about whether or not it was the public, I can see 10.0.0.12. Well, 10.0.0 is the public subnet. Very good. Control V. Very nice. Let's go check out HA and see if HA is finished syncing up. Yep, I see 2 green checks. Synchronization is complete. Let's go ahead and bring up FortiGate 2 by its management IP address. I could go back to my notepad and I would know what its management IP address is, but we are becoming AWS experts. Let's go get it from AWS. So here we go, right? FortiGate HA, FortiGate 2, the only public IP address it has, copy, and we'll paste that into there. And HTTPS : whack whack. There we go. Advanced. Proceed. Admin. Now the password is the same password I just changed it to on FortiGate 1 because that's part of the configuration that synced up. Get this out of the way here. We don't need this. Before we finish testing, there is something that we need to go and edit. Let's go take a look at our route tables in AWS. So we're going to go Services, VPC, and then route tables will be listed right underneath subnets. There we go, subnets, route tables. And private route table routes. This is something that we need to add in. We need to add in a default route that's current, that points to the current master's ENI on the private network. The current master's ENI on the private network. Now, I don't remember what the current master's ENI is on the private network, but I'm going to open up a second connection to the console. I will go to EC2. I know I noted the public one just a moment ago, but I did not note the private. I'll go to the list of instances. The current master is FortiGate 1, so we'll go to FortiGate 1. We'll go to the list of network interfaces, and we need the private network. There's the private network 10.01.11, and there's its ENI right there. So let's say Control-C. And since I'm noting things in Notepad, let's just go FortiGate 1 private ENI and paste that in there. And we'll go ahead and get the other one just because I want to demonstrate something later. ENI, and I'll go to FortiGate 2 and get that. Nope. There we go. ETH1, 10.01.12, this right here, Control-C, come back here, paste. Very good. So I mentioned we need to create a route to whoever the current master is. This is the current master. Copy. Let's go make that routing table entry here. So I'm creating a default route for the private subnet that says to get to the internet, go to a network interface, which one? This is, I'm going to refer back to here. Oh, you know what? They have names. How handy is that? I forgot that they create these with names. Well, it would have been the one that ends in 5EOF, which is this one right here. The FortiGate HA, FortiGate 1, ENI 1. But I jotted down the identifier, so now there's no doubt at all. Click close. Very good. There are some things that I want to set up. So what I'd like to do, I want to set up an HA failover test. I want to purposefully terminate the current master and watch the resources get failed over to the secondary. So let's go over to the secondary. Let's turn on some debugging so that we can see that it makes API calls. Diag, debug, application, AWS daemon, and -1. Diag, debug, enable, please. Very good. Now I've got FortiGate 2 through its individual management IP address, FortiGate 1 through its individual management IP address, and I've also got FortiGate 1 through the clustered IP. The clustered IP, I should get some type of loss of connection with, because as FortiGate 1 fails, that resource is going to get moved over to the other FortiGate, and there will be a bump in connectivity for my management connection. So let's go over to network interfaces, back up to instances, go to FortiGate 1, actions. I'm not going to terminate it, I'm going to stop it because I want to be able to boot it back up later. Stop. Yes, go ahead and stop them. And let's see if our debug gives us any type of output. There was an HA event. Well, the heartbeat got missed. And I see some output here, basically saying I'm supposed to be getting the .13 traffic now. That's how I would roughly translate what's going on there, is please send me the .13 traffic at this point. Say moving secondary IP 10.0.0.13 from this ENI to this ENI, from the ENI with 159 to the ENI with 649. Well, what is 159 and 649? It's FortiGate 1 to FortiGate 2. That's why I jotted those down, because I wanted to be able to confirm that as it went through. And then we see the 1.13, where we see it saying, okay, 1.13 was associated with 5EOF. Now please associate it with ABA4. And if we weren't sure, we could go back and check. 5EOF was FortiGate 1, ABA4. So this is our FortiGate going out and making these API calls. Let me scroll over to the side here. I see update route table, RTB dash, and it's the one that ends in 3444. It says replace route for the destination of 000/0 to my ENI, ABA4. So what he is telling the routing table is, please make me the default route. I'm FortiGate 2, that's my private NIC. I would like to be the default route. So HA is doing what it's supposed to be doing. If we go look at the list of instances now, and we look at FortiGate HA FortiGate 2, and well, first we refresh our output. There we go. There are 2 elastic IP addresses on FortiGate 2. The individual elastic IP, the one that goes to its management interface, as well as the clustered that can fail over back and forth. If we look at the secondary IPs, indeed, it's got the secondary IPs on the new surviving cluster member. Very good. Now I can bring FortiGate 1 back up. It is not going to preemptively take over the cluster. We do not have override priority enabled. Override priority is where the priority number is the second element of consideration for who we make the master or the primary, if you remember that from NSE4 or enterprise firewall from NSE7. So we don't have that turned on, so it's not going to preempt. So I'll go ahead and launch it and tell it to get running again. Or rather, start it, not launch it. Start. Yes, very good. While we're letting that come back up, let's go take a look at our S3 bucket. If I recall correctly, we can go see the bootstrapped configs. There we go. Here's the R-Aslan bucket that I created a little bit earlier. And as we can see, there are 2 files in there, fgt1.txt file, fgt2.txt file. Let's just say download. And we'll open up I won't open up both of them, but I'll open up the fgt2. It's your bootstrapped configuration. What was loaded onto the FortiGate so it initially could function and join HA. Config system interface. We've got some aliases, some IP addresses in here, the .12 IPs, static route. There's a default static route out of port 1. Let's see. There is a set gateway 10.0.1.1 destination. The rest of the 10.0 network, there's a static route that says the rest of the 10.0 network is available out of port number 2, the private network. There is a firewall policy that was created by default, an outbound all policy. We didn't even look at policies because mostly we're focusing on what's unique about deploying in AWS. And if we go down and we look at the HA configuration, I see config system HA, there's a group, active passive, heartbeat device is port number 3, session pickup enable, and we see that there is a dedicated management interface, port number 4, with the 1004 IP address with its own respective gateway. There we go. And it's set up to use unicast heartbeat where its peer is 1003.11. Because it itself is 1003.12, its peer is 1003.11. So that's that bootstrapped config. And the only other thing I would expect to find inside of that S3 bucket is the license file, which we mentioned earlier if you're doing bring your own license. Let's go ahead and close that down there. Let me take a quick look and make sure I didn't forget to bring anything up that's part of the lab number 4 explanations or demonstrations. Nope, that's it. Very good. I am going to continue to use this topology in lab number 5, but I'm going to put lab number 5 in its own video. So we're going to stop this video now, and I encourage you all to meet me in lab number 5. If you're following along on your own and you're stopping here, well, do not forget, there are a couple of ways that you can roll back your configuration. You could go into stack management and delete your stack. Under, CloudFormation template, go into your list of stacks and delete your stacks. Alternatively, you could just go into your instances, delete your instances, make sure your network interfaces delete, your elastic IP addresses delete, and then delete your VPCs. And that would be a lot like what we did at the end of lab number 3, only there would be more things to delete. Make sure you don't leave this lab running very long. This is a larger FortiGate. Oh, by the way, you may have noticed on my currently shared screen, this is the clustered IP and it says it's lost connection. It's because the IP address failed over. If I refresh the browser, yep, there you go. It's going to FortiGate 2 now, but it's still there. So sorry, I just happened to notice that was on my screen. But yeah, don't let this lab run overnight or for days. It's got 2 FortiGates. They are a larger type of virtual hardware, a larger type of instance, and it's got a more expensive pay-as-you-go license associated with it. In general, when I do these labs, I do them all back to back, and then I delete everything when I'm done. It's a whole day affair, really. If you want to do them individually, you can. Just make sure you delete each one as you're done. Don't leave things running overnight. You'll get a big surprise bill. All right, folks, end of the video. I'll see you all in the Lab 5 video.